Hello and welcome to another video about PLC programming. My name is Will, and today we're going to be looking at a little prototype I have for a school project. We are to design a conveyor system that automatically sorts four different shapes. We have 3 good components and then 1 identified as scrap. So I'll show you what I have so far. Okay, so this is our prototype. You can tell it's a prototype by the way that there's wires absolutely everywhere. But let's go through it piece by piece. First things first, we have this VFD, this variable frequency driver. So what this does is it converts the 120 volt single phase coming out of the wall into 220 volt three phase power. Underneath this little plate here, there's some terminal blocks that you can plug into for setting the speed here. This H stands for Hertz frequency of the output. We can also change the direction in here. So I have these wired up into this little relay here. This little relay, we have 1, 2, 3, 4 relays. They are all individually optocoupled to the low voltage side. So that would be our 5 volt input from the Arduino. That's going, or rather, the output. When that's detected, it activates a little light inside of this box, which energizes the bigger switch, which controls our high voltage items. We have a little switch here that is currently a manual / automatic switch. So you can control this. You can control this manually. Currently, the only function I have in the manual mode is just to calibrate the motor. These little Arduino motors here. I was trying to. There's our motor there. I was trying to set something up, but cardboard and foam isn't doing it for me right now. But these little Arduino motors, they can get stuck when they get hot. So if we needed to recalibrate our home position, I can use this little limit switch here, and in the manual mode, I'm able to increment that motor to find our home position. Let's get that pointing at a nice 90 degrees. There we go. We have our stepper motor controller board, which controls that stepper motor, and we have this is a 12 volt DC solenoid, just like you'd find in a car, maybe for like your door locks or something. So this solenoid is going to be what's used to kick the parts out from our feeder onto the conveyor belt. And then once it's kicked onto the conveyor belt, we're going to have a camera system. I'm not on the camera team, so I'm not working on that right now. It's going to kick the part out onto the conveyor belt, and then from there, it'll be identified, and then the logic on the Arduino is going to determine where it goes. For instance, if it is a scrap part, it is going to reverse and throw it into the bucket. We can call that box our bucket. We're currently moving right now, so there's boxes everywhere. Please don't mind the mess. If it is a good part, it's going to come down the conveyor belt, and then the motor is going to position a chute to send the part to any of 3 locations here. So that's how that is going to work. Before I forget, our power source for this DC solenoid is this little 12 volt DC power supply down here. So we have our 3 phase for the conveyor belt, and we have our 12 volt DC for the solenoid. Kind of unavoidable. I wish we could have got a conveyor for cheap that was 12 volts, but that was outside of the budget, so we're borrowing one. But with that out of the way, let's have a look at what the machine does, shall we? We have one of our 3D printed parts here. So this is our hexagon. The hexagon is going to be a scrap part, whereas we have a square, a circle, and a triangle that are supposed to represent the good parts. So when I flick this switch here, this solenoid is going to kick indicating that a part has gone onto the conveyor belt. Then the Arduino is going to use a random number generator to determine what part it is, because we don't have the vision system yet. And then the conveyor belt is going to pick a direction. If it's a good part, it goes to the right. If it's a bad part, it goes to the left. And the motor at the end determines the actual final location for the good parts. So let's give it a shot. You heard that solenoid kick? All right. So this one is going to the right. This one's also going to the right. So these would be like the square or something. So it's going to select the locations for all of these. That's a scrap part. It dumps it off the end. And yeah, that's just about it. We can see the motor over here moving around, selecting the positions. I need to tension that belt. It's making some noise. Let's see that motor move. There we go. And then once the part has dropped off, it returns back to its home position. There we go. And that's just about it. So now we can turn the whole thing off. It'll finish its sort operation, and then it is done. That's the machine so far. Let's go take a look at the code. Okay, so now that we're back at the computer, let's take a look at the Arduino sketch. First things first, we initialize the stepper library. We include that stepper library for our stepper motor control. We tell it how many steps per revolution, our speed that we want to go at. And then we initialize some variables for our input pins. We had to use pull-up resistors in the inputs because there was so much electromagnetic interference. It was toggling things from on to off without any actual input. Before I was coding it into the Arduino, you can actually just initialize it as a pull-up. I was having to wire this on the breadboard myself, which was a little messy, but interesting experience. Now we're just initializing our pins here. We got a couple inputs, which are our two switches, the auto to manual toggle switch and the limit switch that we were using to calibrate the motor. So we have our main loop here. This is where all the magic happens. We've got two write operations here. Basically, what that's doing is just making sure that everything is off prior to the next read through of the loop. The direction switch, obviously that's the direction switch. The calibration trigger, that's our little calibration trigger. Because we're using the pull-up resistors, though, our logic is flipped. High signals do not equal an input. We need a low signal. It's being pulled up to 5 volts by the pull-up resistor. So when we have a low signal, that indicates for it to perform its operation. So it's a little bit of backwards logic here. It's like the difference between normally open and normally closed switches. We have some delays, which I do plan to get rid of once we have our actual physical hardware. But until then, while I'm just simulating, I need to kind of guesstimate what is going to be happening and how long it's going to take. But let's get to it. First things first, it's going to digital write 4 to high. 4 is the pin that is controlling the solenoid. So this is kick out a part onto conveyor. Then we have the random number. It's going to determine what random part is has entered the conveyor. This is to simulate the vision system. It's supposed to be able to sort randomly, so the camera would sense whether it is a square, triangle, circle, or what have you. And at that point, we are going to begin our sorting logic. In the case of the sorting location 1, we are going to move the selector motor like 60 degrees to the left, which equals about 340 steps. That would be for the square part. And then it is, see how we have 5 low? That's initial. That's turning on the conveyor. That's activating that relay, and then it's going to run for 6 seconds, and then move the chute, the depositing chute. It's going to move it back from its sorting position back to the home position. For sort location 2, we're going to assume that that's going to be one that falls straight off. We have one position to the left, one to the right, and we have our home position down the middle. So circle is going to go down into the home position bucket. Position 3 is for the triangle, and it has the exact same logic as number 1. It's going to move the motor to the correct location, and then it's going to move it back, but instead we're moving to the opposite direction. And then if the random number is equal to 4, that's going to be simulating a scrap part, which is in our case the hexagon. So that is, rather than sending it all the way down the conveyor, it's going to run it in reverse and drop it off the back of the conveyor. So it runs for a much shorter time because it's a lot closer to its final destination already. But no need to move the motor. And then we have this else statement here. So this is all assuming that the switch was in automatic mode, and this is for if the switch is in manual mode. If the switch is in manual mode, it's going to print ain't got no gas in it. I know what's wrong with it. Ain't got no gas in it. But then we are actually able to use the calibration trigger, and it will increment the stepper motor. I mean, if I wanted to add another switch, we could choose the direction that we move the stepper motor, or we could, change the speed of the stepper motor. We could do different things, but we're trying to keep this really cheap. So just having the calibration functionality is good enough for me at this point. And then that concludes the cycle. So we can actually watch what the machine is doing through the serial monitor here. I'm gonna go flick the switch really quick. And now it's running. So we'll give it a couple cycles. I don't want that solenoid to kick itself off the table though. Square, we got a triangle. So you see it. I don't know if you can hear it in the background, but the solenoid's kicking. The motor, or this conveyor, is running. Just like we saw in the demonstration, but now we can actually get a readout of what part is being spit out. Probably be a good idea to add a little monitor onto the Arduino for showing which part. Yeah, well, sorry about the names. You got to have some fun with it though. But yeah, a little monitor on the Arduino I think would be a good upgrade. I'll work on that next. But anyways, that's just about it. If you want to see the finished product when it comes out, feel free to hit the subscribe button. Until then, my name is Will, and thank you for stopping by. Bye now. Let's do a little cable management.